All right, this is Honors Algebra 2 in Pre-Calculus. We're doing 7.5 in Algebra 2, which is zeros of polynomial functions, and this is our first video in the section. All right, so let's get started. So the rational root theorem can be used to identify possible roots of polynomial equations with integer coefficients. So basically, this is a theorem, and you can see my note at the bottom of this slide. This is a theorem that is super useful if you're trying to upgrade your educated guessing game for synthetic division. But if you don't want to, you don't have to learn it. It's not a big deal. It is a big time saver, but you'll survive without it. So I'm going to walk you through it. And then the rest of this video is going to be about finding zeros in general. You don't necessarily have to use the rational root theorem, but I'm going to walk you through how this works. So basically, if we consider some polynomial, right, where we have a leading coefficient, right, this 3 is a leading coefficient, and we have a constant term, which is the last term, right, what we do is we call the factors of the leading coefficient, right, we call these q's, right, so the q's would be a 1 and a 3, right, and the p's would be the factors of the constant term, which in this case would be a 1, 2, 4, and 8, all right, and all of the possible roots of a polynomial have to, all the rational roots rather, are of the form x equals plus or minus p over q, meaning these factors over these factors. So what you can see here is if we had factored this answer, right, if we factored this polynomial rather, 3x squared plus 10x minus 8, if we spend some time trying to unfoil that, we're going to get 3x minus 2 and x plus 4. So the two roots end up being x equals 2/3 and x equals negative 4 over 1, or just negative 4. So what I want you to notice is that the green factors, the 2 and the negative 4, they're factors of 8, right? And the red factors, the 3 and the 1, are factors of 3. So essentially the rational root theorem says that there are a ton of possible factors for this, right? So if you wanted to list all the possible factors for this, it's actually plus or minus all the p's over all the q's. So the possible answers would be all the p's, so 1 over 1, 2 over 1, 4 over 1, and 8 over 1, right? So 1 over 1, 2 over 1, 4 over 1, and 8 over 1, all with a plus or minus in front of all of them. And then all the other 4 factors, the other 4 p's over the 3. So 1 over 3, 2 over 3, 4 over 3, and 8 over 3. So it turns out that there's actually 16 possible roots here, and there's only 2 of them that actually are the roots. But if you were trying to upgrade your guessing game when it comes to synthetic division, it wouldn't be worth guessing all the numbers. It would only be worth guessing from this subset of numbers. So for instance, usually we guess 1 and negative 1 and then 2 and negative 2, and then we would try 3 and negative 3. Well, in this case, there's no point in trying 3 and negative 3 because the nice happy number that would work after 2 isn't 3, it's 4, right? So that's kind of the idea. So let's walk through this, and again, if you don't want to pay any attention to this, if you completely want to forget that it's a thing that even exists, that's a choice and it's not a big deal, right? And that's kind of the idea, so let's go ahead. So find all the rational roots of this thing. So basically, there's a couple ways to go, right? One way to go is you could graph this and see what it looks like, right? But all the possible rational roots are going to be the p's, which are the factors of 6, so 1, 2, 3, and 6, over the q's, which are the factors of 10, so 1, 2, 5, and 10, right? So when you're doing your synthetic division, it would make the most sense, right? So if we were looking at the possible answers, it would make the most sense to try plus or minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And then there'd be other factors too. There'd be 1 over 2, 2 over 2, which is just a 1 again, right? 3 over 2, right? And then 6 over 2, which is just a 3 again anyway, right? And then 1 over 5, 2 over 5, 3 over 5, 6 over 5. So this is all the possible roots. And again, you don't have to find all the possible roots. I just want to point out that you could if you wanted. And then all of these numbers over 10. So 1/10, 2/10 is already listed, it's a fifth, 3/10, and then 6/10 is already listed, it's 3/5. So these are all the possible roots, which means that when I'm guessing, I'm going to stick to these numbers probably, right? Now, it might turn out that those numbers aren't correct, but I'm going to start with those as my guessing numbers for synthetic division. Now, there is another option, right? You could use the combination of these possible roots and graphing to get a better educated guess. And again, this is just if you're trying to factor this, right? If you're trying to factor this thing out, you could use this in combination. You don't have to, but you could. Since all you're asked to do here is find the zeros, you could also sort of cheat and just find them on your calculator. But let's walk through what this graph's going to look like. All right. So it looks to me like I definitely have a negative 2 that works, and then some number that's between 0 and 1. So from my eyeballs, right, my eyes tell me that it's pretty likely that x equals -2 works, because that's really likely to be what that spot is. And then there's some answer in the window from 0 to 1, right? Like there's some answer which would pretty much fall in the category of these three or these two. And this one. So one of those options. So let's go ahead and use -2 and see where that lands us, right? We know -2 works, so rather than try 1, -1, 2, -2, I'm just going to jump right to -2 because I know it works. If you don't have a calculator, you would have done the other options first and found that they didn't work, right? And then you would have gotten here anyway. So I drop the number down, multiply, add straight down, multiply, add straight down, multiply, and then I'm not at all surprised that it works because, again, we totally cheated and used the calculator to see that it would work. So I got that the first factor is x plus 2, and what's left is a 10x squared minus 11x plus 3. All right, and then I can factor this. And again, there's some answer in here. We just don't 100% know what it is. So now when I go to factor this, this is either a 5x and a 2x, or it's a 1x and a 10x. I don't know which. And this is definitely a 1 and a 3 with the same sign. So when I go to factor, I am going to go ahead and know that the sign is, since this tells me they're the same sign, I know they're both minuses, so that's a definite, right? And I also know that they're both a 1 and a 3. So really what it comes down to is what the front seats are, right? So it's either a 5 and a 2, right? Or it's a 1 and a 10. Well, it's not going to be the 1 and the 10, because if the 10 is opposite the 3, I get a 30, which is way too big. And if the 10 is opposite the 1, I get a 10 and a 3, which is still not an 11. So it's definitely the 5 and the 2. Seems to me that I want a 6x, right? That would be a 6x. And I want a 5x. And that'll be a -6x with a -5x, which is my -11x. So you can FOIL to check, but that's what you get. And you end up getting that your answers are x is -2. X is 1/2, right? Because I'd add the 1 and divide by 2, right? And x is 3/5, which these are the two answers that on my graph look very close to one answer, which makes sense because one of these is 0.5 and one of them is 0.6. They're very, very close together. If we were to zoom in on that spot, you'll see that there's not just one answer, there's actually two. You can see that it's dipping down below. You can zoom in again, and you'll see that it dips below the axis, right? So those are my answers, right? So that's my answer. Again, I skipped to -2 by using the values that I had on the graph. Now, could you have skipped all of this and just started with 1, -1, 2, -2, and gone right to here? Absolutely, you could have, which is why you don't have to use the rational roots theorem. All right, so for P1, you're going to do the same basic thing. You're going to find all of the rational roots of this particular function. And again, you can use the rational roots theorem if you want as a guideline for how you would pick your values that you'd start with. You can also use the calculator to help you, right? So you could do 12x to the third plus 29x squared minus 31x minus 30, right? And that could inform your decision about what you're going to use to factor. So if we zoom 6, all right, so it looks like there are definitely 3 roots that I can see. The only one that seems to fall squarely on a number seems to be -3, right? And you can look at that, but this one falls near the hash mark but not directly on it. So does this one. So my guess is that -3 is going to work. So could you totally use -3 as a way to inform your guess? Yeah, you could totally use your calculator and say, you know, that's cool. I'm going to go ahead and guess x equals -3, right? You could guess it based on your calculator. And if you tried that, right, you do a -3, and then you have your 12, 29, -31, -30, right? So I drop the 12 down and multiply, add straight down, multiply, add straight down, and then shockingly it works, and I'm not at all surprised because yay, clever guessing, right? So I now know that x equals -3 is one of those rational roots, and if you need to write it, the factor would be x plus 3. What's left, right, this is my number, my x and my x squared, what's left is a quadratic trinomial that I can factor. So when I factor, right, I'm looking for things that are factors of 10, so 1, 2, 5, and 10, right, over factors of 12. So for instance, this could be an x and a 12x, although it's unlikely. It could be a 2x and a 6x, although that's also unlikely. Usually it's the middle set of numbers. So my money's on these, right? I see from the minus that we want things with opposite signs, right? And you could use what you see on this graph to inform your decision. It looks like the negative root is smaller than 1, right? So maybe that helps inform your decision. Maybe it doesn't, right? So I have a 3x and a 4x. I want to find things that will subtract to -7, right? So I look at my options, right? I see that I can try 1 and 10, but that's really not going to pan out because if you put a 10 in either of these spots, you're going to end up with either a 30 or a 40, and that's going to be a problem. So it's not 1 and 10, and unsurprisingly, it's the middle set of numbers, right? It's the 2 and the 5, right? Because I should have really written these the way we normally do, which is sort of in pairs, right? Because it's not just what they're factors of, it's that they have to multiply to 10 together. So 1 and 10 doesn't really work because the 10 is just too big. So it's probably 2 and 5, right? So I say, okay, well, if I put the 5 opposite the 3, right? If the 5 is opposite the 3, I get a 15, and then the 2 and the 4 would give me an 8. Well, 15 and 8 can subtract to a negative 7, so I want a negative 15, right, and a positive 8, and that would give me a negative 7. And then sure enough, you can see where I get these different values, right? I end up getting that this gives me x equals negative 2/3, right, because it would be equal to 0, and I'd subtract the 2 and divide by 3, and this gives me x is 5/4, and sure enough, this root on the negative side is slightly smaller than negative, well, like is smaller in distance from 0, right, is closer to 0 than negative 1, so that fits with negative 2/3, and the 5/4 is just a hair past the 1 hash mark, and that's what 1.25 would be. So again, what I'm doing here is setting each one of these factors equal to 0, but those are my 3 roots, and I can also see them. Now, had you chosen the rational roots theorem, what you'd find is that all of these answers fall in that category of things that are factors of 30 over factors of 12. But again, whether you need to use that or not is sort of up to you. All right, so let's go ahead and find all of the zeros of this particular function, right? Now, this is a special one a little bit because if you look, the only factors that I have for q, rather for my p, is 1, and the only factor that I have for my q is also 1. So the only possible rational roots, right, the only possible rational roots are really, and again, they said find all, not just rational. So notice back in the other examples, this said rational. Right here, we're going to have some that might be something like the square root of 3 or something that could be irrational. So the possible rational roots here are just x's plus or minus 1. That's the only place I can start. Now, I could put this in a calculator to help me, or since I only have 2 guesses, I could just say, you know what, I'm just going to go ahead and do those 2 guesses now because there's not really much to guess. I drop the 1 down and multiply, add straight down, multiply, add straight down, and that doesn't pan out. That's a no, so 1 doesn't work. Negative 1 might, though, right? So 1, negative 2, 1. We drop the 1 down and multiply, add straight down, multiply, add straight down, multiply, and then, hey, there's my 0. So now what I get is that the first root is x equals negative 1, right? That's rational. And what's left, because I have my number and my x squared, what's left is x squared minus 3x plus 1 equals 0. Well, this is prime, meaning it won't factor, but we can use the quadratic formula. So x equals negative b plus or minus the square root of b squared, which will be 9, right, minus 4 times a times c, all over 2 times a. I get that the other roots are 3 plus or minus root 5 all over 2. Okay, so this, right, this is a rational root. These are irrational roots, but I was asked to find all roots, so there you have it, right? Those are my 3 roots, rational and irrational. All right, let's go ahead and do another one. So same situation, right? In this situation, my p's are only 1 and 2, and my q is just a 1. So really, there's only 4 possibilities. You can figure out which one works, right? You can either use a calculator to graph, or you can just say, hey, there's only 4 possibilities for the rational roots. Why don't I just go ahead and check now, right? So if I try this, I drop the 1 down and multiply, add straight down, multiply, add straight down, multiply, and that's a no, because that gives me a 4. I try negative 1 with the same values. I drop the 1 down, multiply, add straight down, multiply, add straight down, and that's also a no, right? That's not giving me a 0. We'll try 2. So if I try 2, I drop the 1 down, I multiply, add straight down, multiply, add straight down, multiply, hey, there's a winner. Cool. All right, so now I know that the first answer that works is x is 2. Great. And then what's left is my number, my x, and my x squared, so I can use the quadratic formula to solve the rest. So x squared minus 4x minus 1 is 0, right? X is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So that's going to be x equals 4 plus or minus, well, this is going to be a 16 plus a 4, so that's a root 20 all over 2. Now that's not wrong, but it's probably better if you recognize that 20 is a 4 times a 5, right? So you can pull that root 4 out and make it a 2. So you would get x is 4 plus or minus 2 root 5, because when you pull the root 4 out, it becomes just a regular 2. So your final answer would be 2 plus or minus root 5. And those would be your 3 roots, right? There's this one, and there's these 2 here. Again, this is not wrong, but you're more likely to see it as a simplified answer. All right, moving on. Again, we're finding all zeros, not just all the rational ones, right? Now here there are more possibilities, right? This is a 1, 2, or a 4, and this is a 1 and a 3. So there's definitely more options. As you start to have more options, it makes more and more sense to put this in a graphing calculator, right? So the more options you have, the less sense it makes to just randomly guess, and the more sense it makes to put it in and make sure that you have reasonable guesses to save yourself time. It's okay to have your calculator do a lot of the brute force. So I go ahead and graph this. Right, and it looks like there's a 0 maybe somewhere around 2, right? And 2 is a possibility here, right? Now, I could be a little lazy and actually second calc 0 and see if it's a 2. And if it's not a 2, that'll inform my decision a little bit, right? So I can go ahead and second calc 0. And it does turn out that it's a 2. So yay, 2 works, right? So once I know 2 works, I can go ahead and use 2, right? And I get 3, negative 10, 10, and negative 4 at the top, right? So we know 2 is going to work. We already have calculator confirmation. So I just go ahead and go through the motions to make it happen, right? So that's a 2, which gives me a 4. Hey, there you go. Not surprised it works, right? So x equals 2. What's left, as far as I can see, what's left has no real solutions. And the reason I say that is we can see the S curve in the graph, right? You see it happens right here. So cubics have one of those S curves, right? And sometimes they look like this, sometimes a cubic looks like this, sometimes it only looks like this, sometimes it's a little bit more like this, but it only has one of those bendy spots, and we're seeing it, and at no point in that bendy spot does this thing hit 0. So my guess is that there are no real solutions based on the graph, right? So my guess, from what I can see, is that there are no real solutions, but that doesn't mean that there aren't zeros, because it said find all the zeros, so we're still going to do the quadratic formula, right? So there's no real solutions, but that's not the same thing as saying there are no solutions. So my x is going to be negative b plus or minus the square root of b squared will be a 16 minus a 4 times a 3 times a 2. And sure enough, 4 times 3 times 2 is bigger than 16. So this is going to come out to be a complex number, right? So a times 2, right? Or 2a. So this is a 16 minus a 24, meaning that this comes out to be a negative 8 inside the root. So I get x equals 4 plus or minus the square root of negative 8 all over a 6. Well, that square root of negative 8, right, is actually a negative 1 times a 4 times a 2. Both of these things can be brought out of the root, and the other two can't, right, because it doesn't have a partner. So I'm going to get x is 4 plus or minus 2i square root of 2, right? There's an I there, all over 6. And if I want to be fancy about it, I can cancel a 2 from here and here. You can't cancel things from in the root, so I can cancel that. And you'd probably see this answer as 2 plus or minus I root 2 all over 3. So these are my roots, right? It happens that this one is real and that these are complex, right? But those are my roots. So go ahead and give P3 a try, and then we'll keep moving forward and we'll talk a little bit more about complex roots. But again, you're finding all the zeros, right? So we want when this thing is 0, right? That's and I should have written that there too. I didn't bother to write that we want when this thing is 0. So this one, I'm curious to see. It does not factor. I thought I would check real quick. So with this one, I'm going to say that with this being such a large number and you not necessarily knowing what numbers go into this, right? It might be worth going ahead and putting it in your calculator now. So if you know what numbers go into 145, that's great, right? So it's definitely a 1 and a 145. It is definitely divisible by 5. And when I do that, I think I get a 29. And both 5 and 29 are prime. So those are the numbers that go into this, meaning if anything, and the only thing that I have for q's are 1. So if anything's going to work, it's going to be one of these 4 numbers. That's it, because my p's are just those 4 numbers, and there's only the one q. So you can either put it in your calculator to check, or you can just do synthetic division. I'm going to go ahead, and it would be these 4 numbers as a plus or minus, right? So it'd still be 8 options, but not quite as bad as it would be if there were options for q's as well. So, so I'm going to go ahead and do 9x squared plus a 49x minus a 145, and we'll go ahead and see if we see anything. So sure enough, 5 seems to work, right? Like I look at my graph, right? I look at this graph and I see this and I'm like, oh, hey, that's definitely 5. Of the options I have, that's definitely 5. So I can go ahead and try 5 and then see what happens. If you didn't have a calculator, you would have gotten to 5 soon anyway, because you would have tried 1 and -1, and then you would have tried 5. Because again, here it's not worth trying 2, 3, or 4, because we understand that they can't possibly be factors of 145. So I drop it down, multiply, add straight down, multiply, add straight down, right, and then multiply and get the 145. So great. There we have the first root, right, is x is 5, which we could see also by the calculator. And what's left is my number, my x, and my x squared. So what's left is x squared minus 4x plus 29 equals 0, right? Once I have that, I already know it's probably not going to factor. In fact, by probably, I know it's not, because 29 is prime, and it's only a 1 and a 29, and there's no way that gives me a -4. So I go ahead and use the quadratic formula, right? I get negative b plus or minus the square root of b squared minus 4 times a times c. This is definitely a larger number than 16, so we're definitely getting something complex, right? In fact, I'm going to do myself a little solid and just do 4 times 29 to make my life easier, right? So that's a 116, right? So this is going to come out to be a nice number, right? Because this is going to be a 16 minus a 116, which is actually pretty nice because it's a -100, but it's still going to have an I. So this is going to be a -100, right, inside the root, which is the same as a root -1 times a root 100. So this is just going to be a 10i. So my answer is going to end up being x equals 4 plus or minus 10i all over 2. We can factor a 2 out of both of those, and I'm going to get 2 plus or minus 5i. Right? So again, I'm setting this function equal to 0 because they said find the zeros, and then I used my calculator to help me cheat a little bit, and or rational roots theorem to help me cheat. I did synthetic division to factor out an answer, and I found my complex answer and my real answer. So there's my answers. There are 3 roots. So let's keep moving forward. All right, that's the end of the first video.